Hello everyone. Today let's solve the problem soldier and the number game. Right. So this was asked in the Codeforces round 304 for the division 2. Right. So what the question states here, you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So just give me a second here. 1 second. Just give me a second. 1 second. Yeah. So here we play with n equals a factorial by b factorial. Just keep this in mind. We are playing with n equals a factorial by b factorial, where a greater than or equal to b. Always remember this one. I just want to remember this part where a is greater than or equal to b. Each round we can choose any divisor, right? X, that is greater than 1, right? So each round we can choose any divisor that is x greater than 1 of current n and replace n by x basically. We can replace n by x basically, right? So the game ends when n equals 1. So when the game ends, basically the game ends 1 when n equals 1. So maximum rounds is equal to the total number of prime factors of n, that is with multiplicity, right? So the maximum rounds is equal to the total number of prime factors of n, that is with multiplicity. For the factorials, this equals, so we can just write it on this form, right? So sigma a, and here we can mention k equals b plus 1, right? So this is fine. For the factorial, this equals this one, right? And this one, capital omega of k, we can just go with the capital omega of k, right? So capital omega of k, this one omega of k is nothing but count of prime factors of k with multiplicity. So this one, just remember this one, count of k, count of prime factors of k, sorry, count of, basically this is completely related to the number theory actually. This is fine. Count of prime factors, so I'll just write here factors of k with multiplicity. Just remember this part, man. This is fine. So yeah, this is the question basically, right? So the game ends when n equals 1, right? So just keep this in mind. So again, let me read out the question loud. Just listen to this carefully. We play with n equals a factorial by b factorial, right? So where a greater than or equal to b. So this part is very important. Each round we can choose any divisor that is nothing but x greater than 1 of current n, and we are replacing n, we can, or we are replacing n by x basically, this part, right? So the game ends when n equals 1. This part, the game ends when n equals 1. Max rounds is equivalent to the total number of prime factors of n with a multiplicity. Again, max rounds is equivalent to the total number of prime factors of n with a multiplicity, right? For factorials, this equals sigma, this one, whatever I have given here, okay, equals b plus 1 and a. So capital omega of k, where omega of k is nothing but the count of prime factors of k with multiplicity, right? So I hope the question part is completely clear, man, right? So what we need to find here, just give me a second. We need to find what is the maximum possible score of the second soldier. That's what we need to find here in this case, right? So we need to find the maximum, sorry, possible score of the second soldier, right? So this is fine. Now let's do one thing. Let's quickly discuss the approach, right? So let's sorry, quickly discuss the approach. First thing here, we didn't consider this one. Let me consider this one, this input output basically, right? So here, uh, one thing we have here is this one, we have 3 1 basically, right? So this is one input, so we have two inputs, so we have two inputs. So one is 3 1 and another one is 6 3, right? So I'll just show for 3 comma 1, and you can just consider for or you can do same thing for 6 comma 3, right? So let's go with the 3 comma 1 first, right? So we will be going with a factorial by b factorial, right? N equals a factorial by b factorial, as I said. So this becomes first step 3 factorial by 2 factorial. Sorry, 1 factorial, not 2. Just give me a second here. Uh, 3 factorial by 1 factorial, a factorial by b factorial. This is nothing but 3 into 2 into 1, 6. 1, this remains same. So 6 will be the answer. So prime factorization or PF, I'll just write here. PF is nothing but the prime factorization. So this we have got the answer 6. This will be basically 3 into 2 or 2 into 3, right? So uh, we have two prime factors, right? So maximum rounds here, I'll just go with basically 2, right? So this one, two prime factors, nothing but 2 into 3, right? So 2 and 3 basically. Max rounds will be 2. So we will be going with the dynamic programming, right? So just remember this one. We will be going with a dynamic programming, right? So whatever the dynamic programming we make use of will pre-compute sigma of this one, sorry, capital omega of I, right? So capital omega of I for all I less than or equal to 5 into 10 to the power of 6, right? So this is what they have given basically in the constraints, right? So 5 into 10 to the power of 6, just remember this one, I less than or equal to 5 into 10 to the power of 6, then builds the prefix sum of this one. We will be building the prefix sum basically. This one will be dp of n equals sigma. This one will be, sorry, just give me a second here. Yeah, this one will be from I equals 2 to n basically. I equals 2 to n, right? Also, we need to consider sigma of I as well along with this, right? dp of n equals sigma from I equals 2 to n sigma, this one, sorry, capital omega of I. So answer would be dp of a minus dp of b equals sigma of k equals b plus 1 to a, right? Sigma of k equals sorry, big omega of or omega of k equals omega of a factorial by b factorial. Just remember this one. Totally will be going with capital omega of a factorial by b factorial, right? Again, dp of this one answer will be equivalent to the dp of a minus dp of b, that is equivalent to the sigma k equals b plus 1 to a capital omega of k equals this one omega of a factorial by b factorial, right? So this is fine. So this is it for the approach basically. So the maximum round that we got here is 2 basically, which is equivalent to the output that they have mentioned for the output 1, right? So within the question, so you can do the same thing for this one 6 comma 3. I insist you to try out for the this one second input that they have given in the question, right? So let me remove this one. Yeah, this is fine. Now we are done with the approach part, right? So as we are completely done with the approach part, we are good to write the code. Let's start writing the code, right? So we'll just come to the compiler here. First, let's do one thing. We'll be making use of fast input output. So let me import here java dot input output dot star. So just give me a second here. This is fine. Now let's do one thing. Let me go with class main. This is fine. So within the main class, so let's do one thing. Let's go with the upper limit. Means I said while explaining the question or while discussing the approach as well, I said that is 5 into 10 to the power of 6, right? So let me go with static here. So this one will be final int n equals, so 5 into 10 to the power of 6, right? So this has to be 4 zeros. So this one I'll just give 1 0. So I'm just going with the upper limit here, right? 5 into 10 to the power of 6 plus we are considering some small buffer just for the this one small buffer to index safely, right? So I'll just go with static here. This one will be long. So this one we are just considering the DP array here, right? So this one will be new long of n. This is fine. So as I've said, we'll be making use of the DP for the pre-computing certain values, right? So I'll just go with static here. So this one will be void pre-compute. So this is fine. Now, so within the method pre-compute, I'll just go with a for loop here. So this one will be int I equals to I less than n. So I'll just go with I plus plus. So within the for loop, what I'll do? So we are just iterating through the candidates, right? From 2 to n minus 1, accordingly with the approach. So if dp of I equals 0, means this implies I is the prime basically, right? So I can just write it in this way. Let me make use of the if condition here. So if iterated value of the dp, if this is equal to the value 0, then let's do one thing. Let me write the for loop here, because for every multiple j, we have to consider the prime I, right? So I'll just go with int j equals I, j less than n, and let me go with j equals j plus I. So this is fine, man. So within the for loop, I'll just go with dp of j, that is equivalent to dp of j by I. So this one will be plus 1. This is fine. Now we are done with this part. Let me come out of this one entirely, man. So let's go with one more this one for loop. So here we will be converting uh, omega of I into the prefix sum basically, right? So this one dp of j equals dp of j by I, whatever I have written, this is nothing but omega of j equals omega of j by I plus 1. So we are just stripping one prime I here, right? So this for loop is nothing but for every multiple j of the we have to consider the prime I basically, right? So that's what we are going with. Now we have to convert omega of I into the prefix sum as we had discussed in the approach, right? So this one for int I equals 2, so I less than n, so this one will be I plus plus. So within this for loop, so let me go with iterated value of the dp equals dp of I plus dp of I minus 1, pure dp, right? So this is fine, man, right? We are just going with dp of I equals sigma of k equals 2 to I, as we had discussed in the approach. The same thing we had written in the form of code actually. Now let's do one thing. Let me go with the main method, man. So now let's go with the main method here. So I'll just come here. So this is fine. So let me make use of here throws input output exception. This is fine, man. So within the main method, what shall I do? I'll just go with a fast input and output, nothing but the buffered reader. So I'll just go with the fast input. I'll just go with buffered reader. So this one will be br equals new buffered reader. So this one will be new input stream reader. So let me go with the system dot in, right? So this is fine. Next, let me do one thing. I'll just make use of the string builder here. So let me go with string builder. So I'll just go with SB here. This is fine. New string builder. This one is fine, man. Finally, let me make use of the pre-compute method that we have already written, right? So within the main method. So I'll just call the pre-compute over here. So this is fine. So next, we have to read the number of queries as well, right? So 3 1, we were given 3 1, the first query. The second one was 6 3 in the example. We have to read the number of queries. This one I'm speaking of, man. The only thing that we have to concentrate here is pre-compute for the case of optimize in this one for the case of optimization basically, right? So here let's read the number of queries. For that purpose, I'll just go with t equals integer dot %. So this is fine. Buffered reader dot read line. This is also fine. Yep, this is fine, man. Now let's process each query. So I'll just write here while loop. So this one will be greater than 0. Now let's read. We have to read A and B. Right. First we have to read A and B. Means in our case it is given 3 and 1. We considered the same thing for the example, right? So for the approach basically. So I'll just go with string. So this one input, so I'll just we have to read a and b, right? So this will be buffered reader dot read line. This is fine. Let me make use of split here, and we have space between the numbers, right? So that is the reason I'm making use of the split here. So now let me go with a and b. So this is nothing but n and m. I'll just go with n equals integer dot percent. So this is fine. So this one will be input of 0. Same thing, let me copy. Let me go with b as well. So let me copy this one entirely. Let me paste it over here, and let me change this one from n to m here also. So this one will be input of 1. This is fine. Now let's do one thing. Let's answer is nothing but sigma of omega b plus 1 to a, right? So that is nothing but dp of a minus dp of b. At last I said the same thing for you, right? So we are making use of the string builder. I'll just go with spring build this one, sorry, string builder dot append here. So dp of n minus a dp of a minus dp of b, in the sense in the code we have considered a and b as n and m. So this will be uh, dp of n minus dp of m basically, right? So this will be dp of n minus dp of m. So this will be, let's append. So we need it in the next line, right? So I'll just make use of the slash in here. This is fine, man. Finally we have to flush all the answers at once, right? So I'll just do one thing. Let me make use of system out println here. So this one, let me pass the string builder, as we are making use of the string builder, right? So this is it for the code basically. So before checking the code with different inputs, what I'll do, I'll just copy paste the signature starter template. Just give me a second here. So I'll just copy paste this one. So let's concentrate on the further part. So I'll just copy the input. So we have to get the output 2 and 3, right? So let's check the same thing. 2 and what we have to get, 2 and 5 we have to get, right? So this is fine. uh, Unclosed character literal. So where is this actually? One second. Line number 49, right? So the same thing basically, unclosed character literal, error not a statement, same thing. 49, let me come to the line number 49. String builder dot append, this one I'm giving, this is fine. dp of n minus dp of m, this is also fine. I'm closing this one over here. So dot append I'm making use of. So this one has to be slash. Sorry, this slash. Sorry. Let me run this one again now. Yeah, we are getting the correct output, right? So yeah, there was a clash between this one, forward slash and backward slash basically. That was the mistake. So this is fine. Now this is working correctly, right? So let me do one thing. Let me copy the entire code. Let me come here. So let me hit the submit button. Let me come to the submission part. Let me select D, right? So this is problem D, soldier and the number game, right? So let me paste the signatures, this one, sorry, this one code, and then let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's see whether this works for all the test cases or not. Let's wait for some time. Yeah, you can clearly see here, right? In the toast it is showing accepted, right? Also the verdict that we are getting here is accepted. Whatever the code that we have written works absolutely correct for all the test cases, right? So we have made use of the DP. So this is fine. Now we have made use of the pure DP, right? Just for the pre-computing purpose, right? So we are done with the solution part. So I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.